Hey guys, today we will be proving 50 trigonometric identities collected from past SPM, UEC, IGCSE, and ICSS textbook. Before we begin, these are some of the important formula that we will use later. Have a look and get used to it. If you want to know how we derive this formula, refer to my Fundamental Trigonometric Identities series. Alright, are you ready? Start off! First question is from textbook. It's very easy. All you need to do is convert this tangent x into sine x over cos x. So left hand side equals to sine x over cos x. Divide by sine x is times 1 over sine x. So sine x and sine x cancel equals to 1 over cos x. 1 over cos x is secant x. Proven. Number 2. Same thing, convert this tangent y into sine y over cos y. Left hand side equals to sine y cos y times sine y over cos y. Cos y and cos y can cancel. So we'll get sine square y. And from basic identity, we know that sine square a plus cos square a equals to 1. So sine square a equals to 1 minus cos square a. We replace the a with y. So 1 over cos square y. Proven. Number 3, tangent and cotangent. As you can see on right hand side, we have secant and cosecant, meaning we need sine and cos. So on left hand side, we convert this tangent into sine theta over cos theta. Then cotangent is a reciprocal of tangent, right? So just flip cos and sine plus cos theta over sine theta. To combine these two fractions together, we need a common denominator. So multiply this fraction here by sine theta over sine theta, and here multiply by cos theta over cos theta. Then sine theta times sine theta is sine square theta. Cos theta times cos theta is cos square theta over cos theta sine theta. And you can see on top is our friend, right? Sine square a plus cos square a equals to 1. So on top we just have a 1 over cos theta sine theta. But we need secant and cosecant. So we split the fraction into 2. 1 over cos theta times 1 over sine theta. On top, 1 times 1 is 1. And 1 over cos theta is secant theta. 1 over sine theta is cosecant theta. Proven. Number 4. For this question, maybe we will start from right hand side because right hand side is more complicated, right? Same thing, we combine the fraction. Equals to this one times here, this one times here. 1 plus sine a plus 1 minus sine a over 1 minus sine a times 1 plus sine a. And on top, simplify, 1 plus 1 is 2. Sine a and negative sine a cancel. So over. Below here, we can use our very familiar friend, 1a plus b. A minus b equals to a squared minus b squared. In this case, our a is 1. So a squared equals to 1 squared equal to 1. And our b is sine a. So b squared equals to sine a squared equals to sine square a. We just have a 1 minus sine square a. Use back the basic identity. Sine square a plus cos square a equals to 1. So 1 minus sine square a, this one move to right hand side, equals to cos square a. Equals to 2 over cos square a. I need a secant square. So I take out 1 over cos square a. 1 over cos square a is secant square a. Proven. Number 5. For this question, I think we start from left hand side or right hand side are the same because they are evenly complicated. Right? So we start from left hand side. Equals to 1 plus cos x over sine x. Because I need a 1 minus cos x on right hand side, right? Which is the conjugate of the numerator on left hand side. So I multiply it by 1 minus cos x over 1 minus cos x. Okay, and then you see on top here equals to 1 plus cos x times 1 minus cos x. Remember our friend, a plus b, a minus b equals to a square minus b square. We'll use it later. For below here, we have sin x times 1 over cos x. See here, our a is 1, b is cos x. So a square equals to 1 square equals to 1, b square equals to cos square x equals to 1 minus cos square x, our friend again, right? And on below here, okay, we don't explain first because later we know that on top we will get a sin square x, right? So don't explain, just let the sin x outside, 1 minus cos x. On top here, we use the basic identity, sin square a plus cos square a equals to 1. So 1 minus cos square a equals to sin square a. Sin square a over sin x, 1 minus cos x. See, our sin x and sin square x can cancel. So we'll get a sin x over 1 minus cos x. Proven. Number 6. As you can see on left hand side, this part here is actually from one of the basic identity, right? Which is the cosecant square a equals to 1 plus cotangent square a. So cosecant square a, we move this 1 to left hand side, minus 1 equals to cotangent square a. We'll start from left hand side equals to sin square x times cotangent square x equals to sin square x. I don't want any cotangent or tangent, so convert it to cos square x over sin square x. Sin square x and sin square x cancel equals to cos square x. Proven. Number 7. Okay, we have some constant here, but don't worry. As you can see, on left hand side we have cos square x, on right hand side we have sin square x. So we know that we have to use a basic identity, sin square a plus cos square a equals to 1. And this 1 here, very lucky we have a 1 here already. So just submit this into left hand side. Left hand side into equals to sin square x plus cos square x plus 4 cos square x equals to sin square x plus 1 plus 4 is 5 cos square x equals to sin square x, because I want to express it in terms of sin x. So cos square a here equals to 1 minus sin square a plus 5 times, I don't want cos square x, right? Equals to 1 minus sin square x equals to, expand the bracket, sin square x plus 5 minus 5 sin square x. Right, so we have a 5 in front. 1 minus 5 is negative 4 sin square x. Proven. Number 8. Wow, we have a 4th degree here, but don't worry. As you can see, secant square x and tangent square x are actually from one of the basic identity, right? Secant square a equals to 1 plus tangent square a. So maybe I get rid of this secant square because I want tangent on left hand side, right? So right hand side equals to tangent square x. Secant square x is 1 plus tangent square x. I don't want secant square. Equals minus 1 plus tangent square x plus with a 1 equals to this tangent, we expand the bracket first, x plus tangent 4th degree x. You see, we got the 4th degree already. Minus 1, then minus tangent square x plus 1. Cancel this tangent square, negative tangent square, then negative 1 and plus 1 can cancel, equals to tangent to the 4th x. Proven. Number 9. Cosecant square plus secant square. Okay, for this one, we will start from left hand side because the left hand side is more complicated. We have 2 terms here, and on right hand side we just have 1 term. Left hand side equals to cosecant square is 1 over sin square theta plus 1 over cos square theta. We just need to combine the fraction, then eventually we'll get 1 term, which is the same as right hand side. Okay, expand the bracket. So cos square theta plus sin square theta on top over sin square theta times cos square theta below. Basic identity, sin square a plus cos square a equals to 1. 1 on top over sin square theta cos square theta. Like the one we did just now, right? 1 over sine square theta times 1 over cos square theta. Split it into 2 so that we'll get the cosecant square theta times secant square theta. Proven. Number 10. We have 2 terms on left hand side and 1 terms on right hand side. We'll start from left hand side. Just combine the fraction and I think we'll get the answer. Okay, on left hand side equals to combine the fraction 1 plus cos A plus 1 minus cos A over 1 minus cos A times 1 plus cos A. You see, on denominator we have our friend A plus B, A minus B. I remind you again, equals to A square minus B square. In this case, our A is 1, so A square equals to 1. Our B is cos A, so B square equals to cos square A. On top, 1 plus 1 is 2. Cos A and minus cos A cancel. Over, we have a 1 square is 1 minus cos square A. And then, basic identity. Sin square A plus cos square A equals to 1. So 1, move this cos square A on the right hand side. 1 minus cos square A equals to sin square A equals to 2 over sin square A. I want cosecant, so I put the 1 over sin square A outside. 1 over sin square A is cosecant square A. Proven. Number 11. On left hand side we have 2 terms. On right hand side we have 1 term. So we start from left hand side. In order to combine them into 1 term, we need to make them into fractions so that it's easier for us, right? So sin square A equals tangent square A equals to sin square A over cos square A. Then minus sin square A is actually equals to sin square A over 1. Okay, so I will multiply the second fraction by cos square A over cos square A so that I will have a common denominator, which is cos square A. So equals to sin square A minus sin square A times cos square A over cos square A. And then on top, we can see that sin square A, we can factor it out. So sin square A equal times 1 minus cos square A over cos square A. You see, our friend again, sin square A plus cos square A equals to 1. We move this cos square x to right hand side equals to 1 minus cos square A sin square A. So equals to sin square A times sin square A over cos square A. Because I want tangent square A on right hand side, right? So we split the fraction into 2. Sin square A over cos square A times sin square A. This one equals to tangent square A times sin square A. Proven. Number 12. Number 12. Right, same thing. We have 2 fractions on left hand side, 1 term on right hand side. Combine the fraction. Okay, so on left hand side equals to this one times this one becomes 1 plus cos x square plus sin x times sin x is sin square x over sin x times 1 plus cos x. And from here we'll use another formula, which is a plus b square equals to a square plus b square plus 2ab. In this case, our a is 1, our b is cos x. So b square equals to cos square x. A square equals to 1. Equals to 1 plus 2 cos x plus cos square x. Then don't forget the sin square x over, we expand the bracket, sin x plus sin x cos x. Okay, as you can see for this part here, it's our friend, right? Sin square A plus cos square A equals to 1. So equals to 1 plus 2 cos x plus 1 over, okay, maybe below we don't explain. Sorry, sin x times 1 plus cos x. Don't expand. So that letter, you see, we have 2 plus 2 cos x over sin x times 1 plus cos x. We can factor out the 2 on top. 1 plus cos x over sin x times 1 plus cos x. See, 1 plus cos x and 1 plus cos x can cancel. Equals to 2 over sin x equals to 2 times 1 over sin x equals to 2 cosecant x. Proven. Number 13. Okay, for this one, obviously we will start from left hand side because it's more complicated, right? And on right hand side, we can see that we have a half angle here. So we need half angle formula. And half angle formula is not given in exam, right? So we need to derive it from double angle formula. We have sine and cos. Let's see, we do sine first. Double angle for sine 2a, I write it for you, equals to 2 sine a cos a. We divide the angle by 2, so sine a equals to 2 sine a over 2 cos a over 2. Sub it into here and here, equals to 2 sine theta over 2 cos theta over 2. Then later 2 sine theta over 2 cos theta over 2. Okay, then for cos we have 3 formulas, right? Let me write it for you. Cos 2a equals to cos square a minus sine square a equals to 2 cos square a minus 1 equals to 1 minus 2 sine square a. And which one to choose? As you can see on top we have a plus 1, we have a positive 1 here. And on right hand side we don't have any constant, meaning we need a negative 1 to cancel out with this positive 1. So I will choose the second one. Cos 2a equals to 2 cos square a minus 1. Half the angle, cos a equals to 2 cos square a over 2 minus 1. Sub it into here. Plus 2 cos square theta over 2 minus 1. Then later plus with a 1. Then what about below? Still we have a positive 1 here. But see, we have a negative in front. So we need a negative 1 plus 1 to make it into 0. I will choose the third one. Cos 2a equals to 1 minus 2 sine square a. Half the angle, cos a equals to 1 minus 2 sine square a over 2. Minus, remember the minus sign in front? Maybe I write into bracket so that we don't make mistake. 2 sine square theta over 2. Then plus with a 1. Okay. On top, this 1 and 1 bye-bye already. And what else? Maybe we write it like this first, 2 sine theta over 2 cos theta over 2 plus 2 cos square theta over 2. On below, 2 sine theta over 2 cos theta over 2. Then minus 1 plus 1 is 0. Minus minus become plus 2 sine square theta over 2. Okay, let's see what we can do now. Okay, we have to factor out the 2 cos theta over 2 on top. Okay, we take out 2, not sine, sorry. We take out 2 cos theta over 2 on top. Then we have a sine theta over 2 plus cos theta over 2. Okay, so later below we can cancel it out. Equals to, on below we take out 2 sine theta over 2. 2 sine theta over 2 times with a cos theta over 2 plus not sine. Yeah, it's sine, sorry. Sine theta over 2. As you can see, this part here and this part here are the same. Cancel. Bye-bye. Equals to 2 and 2 also can cancel. Cos theta over 2 over sine theta over 2 equals to cotangent theta over 2. Proven. Number 14. Obviously, you have to use double angle formula, right? So, I write it for you. Sine 2a equals to 2 sine a cos a. And cos 2a, I write 3 for you. Then we choose cos square a minus sine square a. equals to 2 cos square A minus 1 equals to 1 minus 2 sine square A. As you can see, we have a positive 1 here, and we don't have any constant on right hand side, meaning we need a negative 1. We choose the second one. I choose U. On left hand side, equals to 2 sine A cos A over 1 plus, we choose the second one, right? Sorry. 1 plus, we choose the second one, 2 cos square A minus 1. See, 1 and 1 bye-bye already. 2 sine A cos A over 2 cos square A. 2 and 2 cancel. This square and this cos A cancel, equals to sine A over cos A equals to tangent A. Proven. Number 15. For this question, we start from right hand side. Right hand side is more complicated. On left hand side, we have a cosec. Mean we need a sine. When we need a sine, we cannot have cot, right? We need to convert it into sine and cos. Okay? So cotangent equals to cos y over sine y. Secant is 1 over cos y. So that my cos y and cos y can cancel, equals to 1 over sine y equals to cosecant y. Proven. Number 16. This question we start from left hand side because left hand side more complicated. On right hand side, we have a secant square theta. Mean we need a cos square theta. And we have a double angle here. So, we don't know the double angle of cosecant 2 theta, right? We convert it into sine because we have the formula for it. 2 times 1 over sine 2 theta. Then tangent. Because later I need cos square theta, right? Means I need to cancel out this sine theta or sine square theta, however. So I convert it into sine theta over cos theta. Okay? Double angle formula. Sine 2A equals to 2 sine A cos A. Equals to 2 times 1 over 2 sine theta cos theta times sine theta over cos theta. You see? Our sine theta and sine theta can cancel. And this 2 and 2 can cancel, equals to 1 minus cos times cos square theta equals to secant square theta. Proven. Number 17. For this question, we start from left hand side, okay? On right hand side, we have tangent x, meaning we need sine x and cos x. And we have a double angle on left hand side, but I don't have a formula for cosec. So, convert it into 1 over sine 2x. Same thing, I don't have formula for cotangent. And equals to minus cos 2x over sine 2x. Alright. And as you can see, we have a common denominator. So it's better for us to combine the fractions so that later is easier for us, okay? Equals the common denominator is sine 2x. On top, we have 1 minus cos 2x. I write down the formula for you. Cos 2a equals to cos square A minus sine square A equals to 2 cos square A minus 1 equals to 1 minus 2 sine square A. As you can see, we have a positive 1 here, but we have a negative sign here. So later, if we use this one, our 1 will become positive 1. If we use this formula, our 1 will become negative 1. We need a negative 1, so I choose the third formula. Equals to 1 minus 2 sine square A x. 2 sine square x over sine 2x only have one formula lah. 2 sine x cos x. You see, 1 and 1 can cancel. And negative and negative become positive. 2 sine square x over 2 sine x cos x. 2 and 2 cancel. Sine x and sine x cancel equals to sine x over cos x equals to tangent x. Proven. Number 18. Wow, very complicated, huh? But don't worry. On right hand side, we have tangent. So meaning later we will have a sine A over cos A here. Okay? Then we start from left hand side. Cos 2A, we have 3 formula. Let me write it for you. Cos 2A equals to cos square A minus sine square A equals to 2 cos square A minus 1 equals to 1 minus 2 sine square A. Okay, because later on top we will need both sine and cos. So I will choose the first formula. Equals to cos square A minus sine square A over 1 plus sine 2A only have one formula, which is 2 sine A cos A. And then on top, as you can see, we have A square minus B square. This is actually equals to A plus B, A minus B. In this case, our A is cos A and B is sine square. Sorry, not sine square. B is sine A. On top, we will have cos A plus sine A, then cos A minus sine A. On below, because later we need to cancel out with one of the bracket on top, right? So for that one, we will use the basic identity sine square A plus cos square A equals to 1. We sub this into the 1 sine square A plus cos square A plus 2 sine A cos A. And then for denominator, as you can see, it's very similar form, right? Let me rearrange it for you. Okay, on top we just copy times cos A minus sine A. And then below, I arrange it like this. Sine square A plus cos square A at the back plus 2 sine A cos A. Very familiar, right? It is actually A square plus 2AB plus B square, which is A plus B square. And A is sine A, B is cos A. So we'll have cos A plus sine A cos A minus sine A over bracket sine A plus cos A square. So that this term and this square can cancel. We'll end up having cos A minus sine A over sine A plus cos A. Alright, and then now on top I need the tangent A, right? And we know that tangent A is sine A over cos A. And I need a 1 there. So I will multiply the whole fraction by 1 over cos A on top and 1 over cos A below. So that cos A times 1 over cos A is 1. Sine A over cos A is tangent A. And then sine A over cos A is tangent A. Plus cos A over cos A is 1. Which is equals to 1 minus tangent A over 1 plus tangent A. Proven. Number 19. Okay, later we'll do from right hand side. But we focus on left hand side for a while because I want to get rid of this pi over 4. Okay, so we use the additional formula for tangent. Tangent A plus minus B equals to tangent A plus minus tangent B over 1 minus plus tangent A times tangent B. And in this case, we will just have our left hand side will be equals to tangent A minus tangent pi over 4 over 1 plus tangent A tangent pi over 4. And then we know that tangent pi over 4 is actually equals to 1. So equals to tangent A minus 1 over tangent A times 1 is tangent, sorry, I forgot the 1. 1 plus tangent A times 1 is tangent A. It's very similar to what we did in last question, right? So we now come back to right hand side. Same thing, double angle formula for sine 2A is 2 sine A cos A minus 1 over cos 2A. Which one to use? Because I need both sine and cosine. So I will use cos square A minus sine square A. It's actually very similar to what we did in last question, like this. Alright, so same thing on top, we will use the basic identity. Sine square A plus cos square A equals to 1. But as you can see, on below, we have a cos square A first. So I'm going to write like this. Cos A minus, I write cos square A first. cos square A plus sine square A. So that letter is easier for us to cancel. And now on below, same thing. A square minus B square is A plus B, A minus B. Equals to cos A plus sine A, then cos A minus sine A. On top, to make our life easier, I will factor out the negative. Okay, negative outside. Cos square A, then this one become minus 2 sine A cos A, then this one is plus sine square A over a cos A plus sine A times cos A minus sine A. Same thing on top, we will have a square minus 2ab plus b square, which is equals to a minus b square, where our a is cos A and b is sine A. Equals to, don't forget the negative, cos A minus sine A square. And then on below, copy it, cos A plus sine A times cos A minus sine A. You see, this cos A minus sine A we can cancel. Equals to negative multiply into the bracket. We'll have sine A minus cos A over cos A plus sine A. Same thing, we want to get tangent, so we multiply by 1 over cos A over 1 over cos A. Okay, sine A over cos A is tangent A. Cos A over cos A is 1 over cos A over cos A is 1 plus sine over cos A is tangent A. You see, this one equals to this one. Proven. 20. Okay, for this question, as you can obviously see a tangent square, right? The only formula with tangent square is secant square A equals to 1 plus tangent square A. So, tangent square A equals to secant square A. This one move to the other side, minus 1. And in this case, our A is 1 over 2 theta, which is theta over 2, easier for us to write. Alright, so left hand side equals to secant square theta over 2 minus 1 equals to, and on right hand side we have cos, so we don't want the secant, we convert it back to cos, so equals to 1 over cos square theta over 2, then minus 1 equals to, then now we need half angle formula, and we know that half angle formula is derived from double angle formula. Double angle formula for cos 2a is cos square A minus sine square A equals to 2 cos square A minus 1 equals to 1 minus 2 sine square A. Which one should we use? Because we only want cos, right? So I will take the second one. Cos 2a equals to 2 cos square A minus 1. Half all the angle. Cos A equals to 2 cos square A over 2 minus 1. And as you can see, this part here is very similar to this part. So I rearrange it here. Cos square A over 2 equals to cos A. This one move to the other side, plus 1. Then 2 become divide. Right? And when we take the reciprocal of it, the 2 will become on top over cos theta plus, sorry, this one is not theta. No, not A. This one is not A. It's 1. Plus 1, then minus 1. Combine the fraction becomes 2 minus cos theta plus 1. Theta plus 1. Remember the bracket. Over cos theta plus 1. 2 minus 1 is 1 minus cos theta. And rearrange it. 1 plus cos theta equals to right hand side, proven. Number 21, we have cos 3a on left hand side, but we don't have triple angle formula. So on left hand side, we will let it be cos 2a plus a, because we have double angle formula and additional formula, so we can use it. Okay, let me write for you. Cos a plus minus b equals to cos a cos b minus plus sin a sin b. Sub it into here, we will have cos 2a cos a minus sin 2a sin a. For this part and this part, we know that we can use double angle formula. For cos 2a, we have three formula. The first one is cos square a minus sin square a. Second one is 2 cos square a minus 1. And the third one is 1 minus 2 sin square a. And then you have a look on right hand side. We need a cos cube. And we already have a cos here. And we don't have any sign on right hand side. So I will choose the second one. Okay, 2 cos square a minus 1 times cos a. So that letter cos square times cos, I will get a cos cube. And then minus, for sin 2a, we only have one formula, which is 2 sin a cos a. Then we multiply with sin a, so become sin square a. Equals to, expand the bracket, see, we got our cos cube a minus cos a minus 2 sin square a cos a. But like I said, we don't have any sign on right hand side, so we need to get rid of this sin square. And then the formula that connect both of them is the basic identity. Sin square a plus cos square a equals to 1. So sin square a equals to, this one move to right hand side, 1 minus cos square a. Sub it into here, we have 2 cos cube a minus cos a minus 2 bracket 1 minus cos square a times cos a. You see, we will get another 2 cos cube a, which is what we want. Right? So 2 cos cube a minus cos a minus 2 times cos a minus minus become plus 2 cos cube a. This one and this one put together, we will have 4 cos cube a minus 1 minus 2 become minus 3 cos a. Proven. 22. Same thing, we have 3x here. So on left hand side, we let it be sin 2x plus x equals to additional formula for sin a plus minus b equals to sin a cos b plus minus cos a sin b. In this case, our a is 2x and b is x. Sin 2x cos x plus cos 2x sin x equals to, we use the double angle formula. 2 sin x cos x times cos x become cos square x plus, okay, again for cos 2a, we have three formula. Cos square a minus sin square a, or 2 cos square a minus 1, or 1 minus 2 sin square a. Which one should we use? Because on right hand side, we only have sin, so we cannot use the one with cos. We will choose the third one. 1 minus 2 sin square a, sorry, not a, is x times sin x. When we multiply them together, we will get sin cube x, which is what we want, equals to 2 sin x cos square x plus sin x minus 2 sin square x. Oh yeah, I forgot, we still have another cos square x here. Same thing, we'll use the basic identity. Sin square a plus cos square a equals to 1. So cos square a equals to, this one move to the other side, 1 minus sin square a. 2 sin x times 1 minus sin square a. Then plus sin x minus 2 sin square x equals to, expand into the bracket, 2 sin x minus sin times sin become sin cube x. This one should be x, then plus sin x minus 2 sin square x. 2 sin x plus sin x equals to 3 sin x. Minus 2 become minus 4 sin cube x equals to right hand side, proven. Number 23. Okay, for this question is quite similar to what we have just now, right? Okay, so we will use the tangent additional formula. A plus minus B equals to tangent A plus minus tangent B over 1 minus plus tangent A times tangent B. So in this case, our A is theta, B is 1 over 4 pi is pi over 4. So left hand side equals to tangent theta plus tangent pi over 4 over 1 minus tangent theta tangent pi over 4 equals to, we know that tangent pi over 4 is 1, is a constant. So tangent theta plus 1 over 1 minus tangent theta times 1. Rearrange it, 1 plus tangent theta over 1 minus tangent theta. Proven, right hand side. Number 24. Wow, we have to the 4th degree here. But don't worry, we will reduce it to second power. And then we know that this cos 4x is actually cos square x, then you square it, right? And then this one is actually sine square x, then you square it. Okay, maybe I write it down. On left hand side, we have this minus this. And we can use our friend. A square minus B square is A plus B, A minus B. In this case, our A is cos square x and B is sine square x equals to cos square x plus sine square x. Cos square x minus sine square x equals to basic identity. This one equals to 1 times. This one is from double angle, isn't it? Cos 2x. Cos 2x. Proven, right hand side. Number 25. Okay, we have a very complicated fraction on left hand side, but don't worry. You have a look. We just have a double angle here and double angle here. I write down the formula for you. Cos 2a equals to cos square a minus sine square a equals to 2 cos square a minus 1 equals to 1 minus 2 sine square a. So on left hand side equals to 1 plus, which one should we use here? Because we have a positive 1 here. So I need a negative 1 to get rid of that 1, right? I will choose the second one. 2 cos square x minus 1 over cos x minus 1 minus, because we have minus here. When we multiply it by negative 1, this 1 will become positive 1, this will become negative 1. We need a negative 1 to get rid of that 1. So I choose the third one. 1 minus sine square x over sine x. The whole thing, remember to square. Then, you see 1 minus 1 become nothing. And then this cos x and cos square can cancel. We'll end up having 2 cos x. This 1 minus 1 becomes nothing. And negative times negative become positive. But we still have another negative outside. So it is still negative. Sine x and sine square we cancel. We'll end up having, sorry, we have a 2 here. 2 sine x, then whole thing square. Okay, it's very familiar, right? We have a minus b square is actually equals to a square minus 2ab minus, sorry, it's a plus b square. So we'll have a 4 cos square x plus 4 sine square x. Then minus 2 times 2 times 2 is add sine x cos x. Okay, we don't need the bracket anymore. Equals to, rearrange it. 4 cos square x plus 4 sine square x minus, this one is very familiar, right? We know that sine to a equals to 2 sine a cos a. So we can factor it into 4 times sine x. Sorry, 4 times 2 sine x cos x equals to 4. We factor it out. Cos square x plus sine square x minus 4 times this one is just equals to sine 2x equals to, this one we know that from basic identity is equals to 1, right? Factor out the 4, 1 minus sine 2x. Proven, right hand side. Number 26. Okay, it's a SPM past year question. On left hand side we have 3 terms, on right hand side we have 1 term, so we start from left hand side. Okay, on right hand side we have cos, mean I don't want cosec. Alright, convert it to 1 over sine square x. Then this one minus 2 sine square x minus cotangent is actually equals to cos square x over sine square x. I rearrange it so that we can combine this fraction and this fraction. 1 over sine square x minus cos square x on top, then minus 2 sine square x. Maybe this one I write into the middle. Okay, sine square x. Aha, you see, we can use the basic identity again. Sine square a plus cos square a equals to 1. We move this one to the other side. 1 minus cos square a equals to sine square a. On top, we'll just have sine square x over sine square x minus 2 sine square x. This one equals to 1 minus 2 sine square x. Look at your formula list. It's actually equals to cos 2x. Proven. Number 37. Still SPM past year question. Okay, this one is actually very easy. Okay, on left hand side, we just copy 2 tangent x over 2 minus. Okay, look at your formula list. Which formula has secant and tangent together? Is the secant square a equals to 1 plus tangent square a. So, I will just sub it into here. 1 plus tangent square a equals to 2 tangent x, not a. This one should be x over 2 minus 1 is 1 minus tangent square x. Look at your formula list. This is just tangent 2x. Proven. Number 38. We have cos on left hand side and secant on right hand side. So we will our goal we make it into 1 over cos square x. Alright. We start from left hand side equals to 2 over, okay, cos 2a, we have 3 formula. Again, I will copy it for you. Cos square a minus sine square a equals to 2 cos square a minus 1 equals to 1 minus 2 sine square a. Which one should we use? Look at this. We have a positive 1. We don't want this positive 1. We need a negative 1 to get rid of it. So, second one. 2 cos square x minus 1 plus 1 equals to 2 over 2 cos square x. This one minus 1 plus 1 become 0. 2 and 2 cancel equals to 1 over cos square x equals to right hand side. Proven. 39. We have a tangent on left hand side and a cos double angle on right hand side. Maybe we'll start from left hand side, okay? Equals to tangent, we don't want tangent, just make it into sine x over cos x. For sine double angle, we only have one formula, 2 sine x cos x. And then you see, cos and cos can cancel, become 2 sine square x. It's actually very obvious already, because we know that from double angle formula, cos 2a equals to 1 minus 2 sine square a. So this one move to this side, and this one move the other side. We'll have 2 sine square a equals to 1 minus cos 2a. So straight away, 1 minus cos 2x. Proven. Number 30. Okay, SPM past year came-up question. But don't worry, we'll just use the additional formula for it. Alright, so on left hand side, we have a 2. The compound angle for cos is cos a plus minus b equals to cos a cos b minus plus sine a sine b. Okay, so this will be cos x cos 45 minus sine x sine 45. Then maybe this one I need some space here. Times this thing times cos x cos 45 plus sine x sine 45. We'll quickly get rid of the unknown. We know that cos 45 degree is square root 2 over 2, right? And it's the same as sine 45 degree. So we will have a 2 square root 2 over 2 cos x minus square root 2 over 2 sine x. Then this one is square root 2 over 2 cos x plus square root 2 over 2 sine x. And look at it. It's our friend again. A minus b times a plus b. It is equals to a squared minus b squared. In this case, our a is square root 2 over 2 cos x. When we square it, a squared, this one will become 2 on top and a 4 on below cos square x, which is equals to 1 over 2 cos square x. Then for our b, it is square root 2 over 2 sine x. When we square it, we'll have a b squared, we'll have a 1 over 2 sine square x equals to 2 times half cos square x minus half sine square x. Alright, they will expand the 2 inside, we'll have a cos square x minus sine square x. Look at the formula list, equals to cos 2x, proven. Number 31. Left hand side very complicated. We start from left hand side. On right hand side is just tangent double angle. Okay, so on left hand side, on top we don't touch first, we settle below first. Okay, tangent square and secant square we put together, we know that we have to use a basic identity. Let me show you. Secant square a equals to 1 plus tangent square a. So when we move this to the other side, tangent square a minus secant square a will get a negative 1, which is what we have here. I think I rearrange it first. Square minus secant square x plus 2 cos square x equals to, you see, this part here will become negative 1. So sine 2x over 1 minus 2 cos square x. Look, this part here is just cos 2x. So we have a sine 2x over cos 2x equals to tangent 2x. Proven. Number 32 is quite similar, right? We have a double angle on right hand side. So left hand side, I don't want tangent because we only have sine on right hand side. I convert it into sine theta over cos theta times cos square theta. Cos and cos cancel equals to 2 sine theta cos theta. Look at the formula list. Sine theta. 33. This is also very similar, right? So we use the additional formula for sine. Sine a plus minus b equals to sine a cos b plus minus cos a sine b. In this case, our a is 3x and our b is pi over 6. For this question, on left hand side, we'll have a sine 3x cos pi over 6 plus cos 3x sine pi over 6 minus sine x cos pi over 6 minus cos 3x, then sine pi over 6. Okay, press your calculator. Sine pi over 6 is actually equals to 1 over 2. And then cos pi over 6 will be square root 3 over 2. Okay, substitute it inside. We will have square root 3 over 2 sine 3x plus 1/2 cos 3x minus square root 3 over 2 sine 3x. Sorry, this one should be sine 3x. My mistake. Minus half cos 3x equals to this one and this one can cancel. Then negative, when you expand inside, become positive. Half plus half become 1. So cos 3x. Proven. Number 34. Okay, question from last year. I still remember this question. It's actually very easy. Don't be scared by this half angle. Right? Just let this half angle be something else, maybe a u. So a equals to 2u. When you change it to 2u, we can use double angle formula. Okay, I write it down for you. Right hand side equals to 1 over cos 2u over sine 2u. For cos double angle, we have 3 formula, which is cos square a minus sine square a, or 2 cos square a minus 1, or 1 minus 2 sine square A. Which one should we use here? You look at it carefully. We have a 1 here, and we have a negative sign here. In order to get rid of that 1, we need another negative 1 to make it into 0, right? But we have a negative sign in front. When we multiply it by a negative 1, this one here will have a positive 1. This one here will become a negative 1. Therefore, we will choose the third formula. Equals to 1 minus bracket 1 minus 2 sine square u over sine 2u already have one formula. Sine double angle is 2 sine u cos u. You see, very easily, this 1 minus 1 will become nothing. And negative exponent inside will become positive. So, 2 sine square u over 2 sine u cos u. 2 and 2 cancel. Sine u and sine square this one cancel. Power minus 1 equals to sine u over cos u. Equals to tangent u. What is u? U is a over 2. So, equals to tangent a over 2 equals to left hand side. Proven. Number 35. You look at it. It's very similar to last year's question, right? I purposely put them together. This is actually a question from UEC in 2010, right? So, same method. I think you know already. We let this x over 2 be u. So, x equals to 2u. On right hand side, we have sine 2u over 1 plus cos 2u. So that we can use the double angle formula. For double angle sine, we only have one formula, which is 2 sine u cos u. Then 1 plus, again I will write down for you, cos 2a equals to cos square a minus sine square a. Or 2 cos square a minus 1 or 1 minus 2 sine square a. Which one should we use? We have a positive 1 here. So we need a negative 1. Don't worry, it is a positive sign in front. So we just choose a second one. 2 cos square u minus 1 equals to 2 sine u cos u over 1 minus 1 becomes nothing. 2 cos square u. 2 and 2 cancel. Cos and cos cancel equals to sine u over cos u equals to tangent u equals to tangent x over 2. Proven. Number 36. Okay, have a look. We have a 3 theta on left hand side, but we don't have a triple angle formula. The only way for us to do it using the formula that we have is, we let left hand side equals to sine 2 theta plus theta over sine theta plus cos 2 theta plus theta over cos theta. Alright, then you can use the compound angle formula. Sine 2 theta cos theta plus cos 2 theta sine theta over a sine theta. Same thing for the second fraction. Plus cos 2 theta cos theta minus sine 2 theta sine theta over a cos theta. And then we have the double angle here. Sine 2 theta is 2 sine theta cos theta. But we have to multiply another cos theta here. So it will just be cos square theta plus cos double angle. Again, I'll write it down for you. Cos 2a equals to cos square a minus sine square a, or 2 minus or 2 cos square a minus 1 or 1 minus 2 sine square a. Which one should we use here? Because as you can see later, this sine and this sine theta will cancel. And we have a cos square here. So I will choose the second one. Okay? 2 cos square theta minus 1 times sine theta over sine theta. Then for this fraction here, which one should we use? Later this cos theta and this cos theta will cancel. We need a sine square theta later. We will have a sine square theta when we multiply them together. So I will choose the third one. 1 minus 2 sine square theta times cos theta minus 2 sine theta cos theta times 3 sine theta, so becomes sine square theta over cos theta. Alright. Then sin theta, sin theta, sin theta cancel. Cos theta, cos theta, cos theta cancel. We will end up having 2 cos square theta plus 2 cos square theta minus 1 plus 1 minus 2 sin square theta minus 2 sin square theta equals to minus 1 plus 1 become nothing. 2 plus 2 is 4 cos square theta. Minus 2 becomes minus 4 sin square theta. Factor out the 4 cos square theta minus sin square theta. It is equals to 4 times cos 2 theta. Proven. Number 37. Okay, cube half angle again. Don't worry, we'll start from right hand side. Because it's multiplied, so we can straight away put them together. Cos alpha, double angle for sine is 2 sine alpha cos alpha. Over denominator, multiply them together. 1 plus cos alpha times 1 plus cos 2 alpha. Okay, this double angle again, cos 2a equals to cos square a minus sine square a, or 2 cos square a minus 1, or 1 minus 2 sine square a. Which one should we use? Look at it. We have a positive 1 here, and it's a positive sign here. We need a negative 1, so we choose the second one. I straight away put it into the bracket here. 2 cos square alpha minus 1. This cos and this cos multiply together, we will have a cos square alpha over 1 plus cos alpha times 1 minus 1 becomes nothing. 2 cos square alpha. As you can see, this 2 and this 2 can cancel. This cos square and this cos square can cancel. We end up having sin alpha over 1 plus cos alpha. You see, it's quite similar to what we have just now, right? Maybe we go back to question number 35. This is what we have in question number 35. So you just refer to question 35. I don't want to do it again. It's the same. Okay? 38. Fourth degree again. Don't worry, I told you this is actually equals to sin square theta square, and this is actually equals to cos square theta square. And we know that a plus b square equals to a square plus 2ab plus b square. So if it is only a square plus b square, we move this one to the other side, equals to a plus b square minus 2ab. In this case, our a is sin square theta, while our b is cos square theta. And this is left hand side is just equals to sin square theta plus cos square theta square minus 2 sin square theta cos square theta. Basic identity. 1 square is still 1 minus 2 sin square theta cos square theta. Proven. I forgot to tell you, the reason we always reduce it to second power is because you look at your formula list. A lot of formula are having cos square, sin square, right? So when we reduce it to second degree, it's always easier for us to find the suitable formula to use. Therefore, we always do this, right? Number 39. Okay, we start from right hand side. It's more complicated, right? Tangent is sine over cos. And on below, don't straight away convert. For below, don't straight away convert. Look at it carefully and look at your formula list. Yes, 1 plus tangent square A equals to secant square A. Secant square A, don't convert, equals to 2 times sin A over cos A times 1 over secant square A. 1 over secant square A is just 1 over secant square A is cos square A. Cos and cos square cancel, 2 sin A cos A. Again, look at the formula list, is equal to sine 2a. Proven. Number 40. Okay, UEC question. On left hand side is very complicated. On right hand side, we have a triple angle. We know that it's impossible to straight away get a triple angle, right? So, for this question, maybe we will do from left hand side first until we reach a certain step. And we do from right hand side until we reach the same thing as it. Hopefully we can do that, huh? Alright. So, left hand side, we expand the bracket. This one times this one is sine 2x. This one times this one is negative 2 sine x cos x. And we know that this is actually equals to sine 2x. Okay? And this time this is negative sine x. This time this is plus 2 sine 2x cos x. Okay? Sine 2x and negative sine 2x can cancel. And I rearrange it. 2 sine 2x cos x minus sine x. Okay. We have a double angle here. Use a formula for double sine is 2 sine x cos x times with a cos x minus sine x. Then we expand the bracket. 2 times 2 is 4 sine x. Cos times cos is cos square x minus sine x. What else we can do? Maybe we just stop here for left hand side. Okay, we start from right hand side. Right hand side equals to, I told you, sine 3x is sine 2x plus x. You should know that already. Then additional formula for sine, sine 2x cos x plus cos 2x sine x. For sine double angle, we only have one formula, which is 2 sine x cos x. Cos x times cos x is cos square x. Then plus, we have to choose again. Cos 2a equals to cos square a minus sine square a. Or 2 cos square a minus 1. Or 1 minus 2 sine square a. Which one should we choose? Which one should we choose? You have a look. We have a 4 sine x cos square x here. But until now, on right hand side, we only have 2. And we want another 2 sine x cos square x, right? So we need cos square x because we only have sine x here. But I don't want sine to become cube. So I will not choose the one with sine. I will choose the second one. 2 cos square x minus 1 times sine x. You see? 2 sine x cos square x plus 2 sine x cos square x minus sine x. 2 plus 2 is 4 sine x cos square x minus sine x, which is equals to this. And this equals to left hand side. Proven. Okay, number 41. Question from ICSS. For this question, I will do from right hand side. Because you see right hand side, we have a cotangent. And on left hand side, we have sine and cosec. Basically means sine, right? So, I want to get rid of this cos. On right hand side, cotangent is cos theta over sine theta times with a cos theta. We are now having cos square theta over sine theta. I said I want to get rid of this cos, right? So, I will use the basic identity. Sine square A plus cos square A equals to 1. So, cos square A equals to this one, move to the other side, equals to 1 minus sine square A. Right? Equals to 1 over sine square theta over sine theta. And here, we can separate the fraction into 1 over sine theta minus sine square theta over sine theta. 1 over sine theta is cosecant theta minus sine and sine square can cancel, become sine theta. And proven. 42. For this question, we'll do from left hand side. It's more complicated, right? So left hand side, we combine the fraction this one times this one times this one, becomes sine x times sine x, sine square x, plus, as you can see, this one and this one are actually the same. So I straight away write down 1 plus cos x square over, maybe I write sine x in front, times 1 plus cos x equals to, we expand this bracket, the bracket is square, plus 1 plus cos square x plus 2 cos x over, okay, I think we have to keep this so that later we can cancel. Okay, so and now you see this one and this one when you put together is actually the basic identity. Sine square a plus cos square a equals to 1. Maybe I write it down for you. Plus cos square x plus 1 plus 2 cos x over a sine x 1 plus cos x. Don't touch, later we can cancel it. So this part here is just equals to 1 plus 1, so is 2 plus 2 cos x over sine x times 1 plus cos x. Factor out the 2 on top, 1 plus cos x. This is a reason why just now I didn't expand the bracket. See, we can cancel it out. Equals to 2 over sine x equals to 2 times 1 over sine x equals to 2 cosecant x. Proven. Number 43. This one, our friend again. See, a minus b times a plus b equals to a square minus b square. This is very useful, you see. And in this case, our a is 1, so a square is 1. B is sine a, so b square is sine square a. On left hand side, we have 1 square is still 1 minus sine square a over cos a over sine a cos a. Okay? On top, see, is basic identity. Sine square a plus cos square a is 1. When we move this to the other side, 1 minus sine square a equals to cos square a. Cos square a over sine a times cos a. Cos and cos square cancel equals to cos a over sine a equals to cotangent a. Proven. Number 44. Two fractions on the left hand side. We do from left hand side. Combine the fraction. 1 plus cos x minus 1 minus cos x. Below is our friend again, right? 1 minus cos x times 1 plus cos x. Never mind, we will settle it later. 1 minus 1 is 0. And this negative become positive. 1 plus 1 is 2 cos x over our friend a minus b times a plus b is a square minus b square. A is 1. A is 1, a square is 1. B is cos x, so b square is cos square x. We will have a 1 square minus cos square x, our friend. It's actually very similar to what we did just now. Sine square a plus cos square a equals to 1. Move this to the other side. 1 minus cos square a equals to sine square a. Alright. We have 2 cos x over a sine square a. But you have a look on right hand side. We need a cosec and cotangent. So we just split this part here into sine a times sine a equals to 2 constant we put outside, cos x over sine x times 1 over sine x equals to 2, this one is here, cosecant x, and this one I put here, cotangent x. Proven. Number 45. Same thing lah, left hand side equals to 1 plus sine x minus 1 minus sine x over 1 minus sine x times 1 plus sine x. On top, 1 minus 1 is 0. Sine x minus sine x is 2 sine x over our friend a minus b. A plus b is a square minus b square. A is 1, a square is 1, b is sine x. So b square is sine square x. Below we'll have 1 minus sine square x equals to basic identity sine square a plus cos square a equals to 1. So move this to the other side. Cos square a equals to 1 minus sine square a. We have a 2 sine x on top and cos square a below. And because we need tangent and secant, we split this cos square x into cos x times cos x. 2 put outside, sine x over cos x times 1 over cos x equals to 2. This is tangent x, this is secant x. Proven. Number 46. Alright, you have a look. We have a cos theta on right hand side and secant theta on left hand side. Meaning we need to convert it into 1 over cos theta. Then minus sine theta over cotangent is cos theta over sine theta. And for this one here is actually equals to, maybe I do it aside. If we have a divided by b over c, is actually equals to a times c over b, which is ac over b. In this case, our a is sine theta, our b is cos theta, and our c is sine theta. We end up having sine square theta on top and a cos theta below. This is 1 over cos theta. Common denominator can combine fraction. 1 minus sine square theta over cos theta. Basic identity, sine square a plus cos square a equals to 1. Move this to the other side. Cos square a equals to 1 minus sine square a. On top it is just cos square theta over cos theta. Cos theta, cos square cancel equals to cos theta. Proven right hand side. Number 47. I remember this question from last year IGCSE. It's very special. It's not that you straight away prove that this one equals to this one. Okay? You need to prove that this equals to 0 and eventually you simplify, you will get this. Okay? So no left hand side, right hand side lah. It's an equation. We will start with the first one. 13 tangent x is equals to sine x over cos x. Secant x is 1 over cos x minus this 4 sine x minus 5. Secant square is 1 over cos square x equals to 0. And this one, 13 sine x over cos sine cos is cos square x. Then maybe I put this here. Minus 5, 1 over cos square x minus 4 sine x equals to 0. Common denominator, combine the fraction. 13 sine x minus 5 over cos square x minus 4 sine x equals to 0. But you see, our final answer only have sine, right? Meaning we need to get rid of this cos. How should we do that? Basic identity. Sine square a plus cos square a equals to 1. So move this to the other side. Cos square a equals to 1 minus sine square a. Alright, so we have minus 5 over a 1 minus sine square x minus 4 sine x equals to 0. Very close already, huh? We only have sine now. Then combine fraction. How should we do that? This one is actually equals to 4 sine x over 1. So in order to combine the fraction, we'll multiply it by 1 minus sine square x over 1 minus sine square x. So that we have common denominator and we can combine the fraction. 13 sine x minus 5 minus 4 sine x times 1 minus sine square x over a 1 minus sine square x equals to 0. To simplify, we expand the bracket first. Oops. We expand the bracket first. 13 sine x minus 5 minus 4 sine x. Then minus minus become plus, and sine times sine square become sine cube. Plus 4 sine cube x over 1 minus sine square x equals to 0. Collect all the like terms. 4 sine cube x I write in front. 13 minus 4 is 9 sine x. Then minus 5 over 1 minus sine square x equals to 0. I told you already, this question is very special. It's not that we are proving identities, but we just have to prove that this can be written as this. So we multiply both sides by 1 over sine square x. We have 4 sine cube x plus 9 sine x minus 5. This one times 0 is 0. So, short. Number 48. Okay, we do from left hand side. Combine the fraction. This one times this one times this one. Tangent times tangent is tangent square x. Plus, it's the same thing. 1 plus secant x square. Divided by 1 plus secant x times tangent x. On top, we expand the bracket. Equals to tangent square x plus 1 plus secant square x plus 2 secant x over below we all below I think no need. We just keep it like this. Later we can cancel out. Okay? And now you see this part here is very similar. We have one of the formula, which is secant square a equals to 1 plus tangent square a. Secant square x plus 2 secant x plus secant square x over tangent x 1 plus secant x. So we have a 2 secant square x plus 2 secant x over the tangent x 1 plus secant x. On top, we can factor out 2 secant x. So secant x plus 1 over a tangent x 1 plus secant x. This and that can cancel. I write here 2 secant x over a tangent x. So I need a 2 over sine x. 2 secant x is 1 over cos x. Divided by tangent x means times 1 over tangent x. 1 over tangent x is cotangent x. Cotangent x is cos x over sine x. Cos and cos cancel equals to 2 over sine x. Proven. Number 49. Number 49. We will do from left hand side. Equals to cosecant is 1 over sine x. Cotangent is cos x over sine x. Below don't touch, 1 minus cos x. Equals to, we factor out 1 minus sine x so that I will have a 1 minus cos x which can be cancelled with below. I get a 1 over sine x which is cosecant x. Very happy. Number 50, last question. Alright, on left hand side, we have cosecant is 1 over sine. Cosecant 1 over sine minus sine theta. Then because we have a secant square on right hand side, we'll multiply it by sine theta over sine theta. So that I will have a sine square. So that I will have a 1 minus sine square on below and equals to cos square. Equals to 1 on top over a 1 minus sine square theta. Sine square A plus cos square A equals to 1. 1 over cos square theta equals to secant square theta. And we are done.